All right, let's dive right into today's explainer. We're going to unpack a really fascinating shift that's happening right now in enterprise tech. It turns out building smarter clouds doesn't just save you a ton of money, it actually drastically lowers your carbon emissions too. We're talking about GreenOps, and more specifically, how artificial intelligence is stepping up to completely optimize the way we consume cloud resources.
Think about this for a second. Can AI actually shrink your cloud bill and your carbon footprint at the exact same time? For a long time, there was this lingering assumption in IT that you had to choose between extreme system reliability and environmental responsibility. But achieving both, it's no longer just some theoretical concept. It's a proven, data-backed reality. Today, we're going to see exactly how enterprises are leveraging AI to slash both their infrastructure bills and their greenhouse gases simultaneously.
And the stakes here are absolutely massive. Global data centers currently consume around 200 terawatt-hours of energy every single year. But here's the truly crazy part. Research shows that traditional high-availability clusters actually waste 60 to 80% of their provisioned resources. That capacity is just sitting there, completely idle, waiting for a traffic spike that honestly might never even come, all while continuously burning through both power and your budget.
To fix this, we desperately need a pragmatic paradigm shift, and that brings us right to GreenOps. This framework shows us exactly how we can hold our cloud estates both financially and environmentally accountable. It's all about building a culture where software engineering, cloud architecture, and sustainability are fully integrated. You aren't just optimizing for speed anymore, you're literally optimizing for the planet.
When you look at how this maps from the raw data over to operations, things get really interesting. By smashing FinOps, which is your financial operations, together with GreenOps, organizations are gaining this unprecedented level of visibility. You establish your benchmarks, really understand the telemetry, and suddenly you have the power to optimize your IT estates, tackle climate change, and crush your corporate sustainability reporting all at exactly the same time.
So how do we actually pull this off? Well, it essentially comes down to rethinking how we scale. Think of traditional threshold-based scaling like a basic, old-school thermostat. It only reacts and kicks on when the house is already too hot, which is slow and almost always over-provisions resources. Predictive AI scaling, on the other hand, is like a smart thermostat that proactively checks the weather forecast and cools the house perfectly on time. It completely eliminates that idle waste before it even happens.
Under the hood, this predictive capability relies on some seriously fascinating machine learning models. We're looking at long short-term memory, or LSTM neural networks. These models analyze multivariable telemetry data, things like CPU usage, memory, and API request volumes, to anticipate your demand hours in advance. It also uses deep Q network reinforcement learning and even real-time API integrations with actual energy grid operators to know precisely when to scale up or down.
And that real-time grid integration unlocks something I think is just brilliant: carbon-aware computing. This is the practice of shifting your workloads either temporally, meaning shifting them in time, or geographically, to execute exactly when and where the local power grid's carbon intensity is at its absolute lowest. The AI intelligently schedules your flexible batch jobs or heavy deep learning workloads for the exact moments when renewable energy, like wind or solar, is most abundant on the grid.
For all the DevOps and platform engineers tuning in, let's actually trace this out in a real-world enterprise architecture. It starts right at a developer's commit, flows smoothly through your standard CI/CD pipeline, and directly into Kubernetes. But right here, an AI optimizer steps in. It acts as this intelligent, carbon-aware scheduler, deciding exactly how and where to place that workload into your AWS, Azure, or Google Cloud environment before finally feeding all those savings right back into a sustainability dashboard.
Now look, this setup isn't just about getting a gold star for being green. It delivers massive, highly tangible business benefits. By implementing this pipeline, enterprises are seeing up to 40% savings in their FinOps cloud costs. You are drastically reducing both your monthly infrastructure bills and your carbon footprint while pushing your resource utilization through the roof, all without sacrificing a single ounce of performance.
To see what this actually looks like in practice, check out this sustainability dashboard from Zabbia, which is tracking their carbon reduction by cloud product. Notice how they have this total top-down visibility into their AWS services. They can see exactly how many kilograms of CO2 equivalent are being generated, successfully transforming abstract cloud data into actionable, highly accountable metrics.
And if we dive just a bit deeper, these specific views perfectly demonstrate how incredibly granular this telemetry data gets. You can track your costs and emissions side by side, literally broken down by specific microservices or individual EC2 instance types.
Having this level of insight is an absolute game changer, because once you know exactly which parts of your architecture are the heavy emitters, you know exactly where to point those AI optimization tools for maximum impact.
This certainly isn't limited to niche tech startups either. Major high-traffic e-commerce players like the WeCamp Retail Group, a massive Dutch online retailer, use these highly optimized serverless architectures on AWS. They're handling petabytes of data to serve their customers, completely proving that GreenOps and AI-driven efficiency can scale effectively at a massive enterprise level to support mission-critical systems day in and day out.
When you actually crunch the research data, the return on investment of this AI-driven model is staggering. Studies looking at production Kubernetes clusters deployed across the major cloud platforms saw an average 31% reduction in carbon emissions, a 28% drop in overall energy consumption, and a 23% savings in direct infrastructure costs. It is just a massive win across the board.
Now, I know exactly what you infrastructure engineers are thinking right now. Okay, but what about my uptime? Well, the best part of this data is that this level of AI optimization still guaranteed a 99.95% availability SLA. The system utilizes a strict rule-based safety layer that simply overrides AI decisions if reliability risks exceed certain thresholds. It proves definitively that you do not have to choose between system reliability and the environment.
And it doesn't stop at the software layer. This efficiency goes right down to the bare metal. Even at the physical infrastructure level, AI models managing thermal-aware scheduling and deep reinforcement learning for cooling systems have demonstrated over 22% total energy savings in active data centers. The AI is literally learning the optimal cooling strategies just by interacting with server temperatures in real time.
So how can you actually start doing this in your own stack? Well, one immediate, highly actionable step is modernizing your legacy code by shifting from infrastructure as a service, or IaaS, to serverless paradigms. By utilizing serverless functions like AWS Lambda or Azure Functions, you only consume power for the exact seconds your code is actually running, rather than paying for a server to just sit idle all day waiting for a request. Let's quickly recap the key actionable steps you can run with today. First, establish your baseline telemetry, because you simply can't manage what you don't measure. Next, transition those idle workloads over to serverless functions. Implement predictive AI-driven auto-scaling in your Kubernetes clusters to finally stop over-provisioning. Utilize geographical load balancing to actively chase clean energy on the grid. And lastly, adopt standard carbon accounting tools to track your true environmental footprint. As we wrap up, I want to leave you with a bit of a provocative question. With all of the AI tools, predictive models, and serverless architectures available to us right now to optimize our infrastructure, how much longer can your enterprise genuinely afford to just waste 60% of its cloud capacity? The tools are right here, the financial savings are real, the time to optimize is definitely right now.
If you got something out of this explainer and want to help us share this incredibly critical GreenOps strategy with the broader tech community, please hit that like button, share, and subscribe. And I'd love to hear from you. Drop a comment down below on how you think AI can improve sustainable cloud operations in your own day-to-day projects. Thanks for joining me on this deep dive, and keep